In this video, we are going to talk about exponents.
Using an exponent means that you're taking a number and multiplying it by itself. The exponent tells you how many times you're supposed to multiply that number.
If you're given 7 raised to the second power, meaning it is just 7 times 7 itself. 6 to the second, it's just 6 times 6, which is 36. So 2 to the fifth, it's just 2 times 2 times 2 times 2 times 2, 5 times. That is 32. How about 3 to the third, right? So meaning 3 would multiply itself 3 times. So 3 times 3 times 3 is 27, right? How about -1 to the fourth? -1 multiplied by itself 4 times. So that would be -1 multiplied by -1 2 times, and then -1 3 times, and then -1 4 times. So -1 times -1, and negative times a negative is a positive, and 1 times 1 is 1, right? And then the second group, negative times negative, is going to be positive. So 1 times 1 is again 1. So that would be +1. So we have 1 times 1. So that would be 1. Some special case for the exponents. So with the exponent 1, any number that is raised to the first is going to be equal to itself. 8 to the 1 is 8. How about 100? Raised to the first order is still 100 itself. 56 to the 1 is 56. How about -5 to the first power? It is still -5. And the second case is any number raised to 0 is going to be 1, regardless of what number. So we have 2020 raised to 0 is going to be 1. -2 raised to 0 is going to be 1. Alright, so speaking of the negative exponents, if we have 5 raised to the -1, what is that? A raised to the -2, what is that? So the two steps to take care of the negative exponents would be, first, we calculate that number like it has a positive exponent, and then we flip it, taking it its reciprocal. What do I mean by these two steps? 5 to the -1, we want to treat it as a positive exponent first, right? So that'll be 5 to the 1 is 5. And then in the second step, we want to flip the result. We take the reciprocal of 5. So that would turn into 1/5. So how did it go from 5 to 1/5? 5 can be written as 5/1, right? 5 divided by 1 is 5. So 5 is 5/1. To flip 5, I convert it into a fraction. That would be 5/1. And then we flip the fraction 5/1. So that would be 1/5. The answer to 5 to the -1 would be 1/5. So how about 8 to the -2? Again, in step 1, a to the negative 2, we want to treat this negative 2 like a positive exponent. So how about a to the 2, right? So a to the 2 is a times 8. That is 64. Okay, and then in the second step, to flip it, 64 divided by 1. So now we have a fraction form. We can go ahead and take its reciprocal form. That'll be 1 over 64. In short, that'll be a to the negative 2 is going to be 1 over 64. Some notes: in case where we have the parentheses with the exponents in the same expression. This example, 4 times 3 to the second, is not the same as parentheses 4 times 3 close parentheses, and all of that, the entire parentheses raised to the second power. Let's see what each expression evaluated to. So 4 times 3 squared, this has a multiplication, and this is an exponent. We have two different operations. So which one should we prioritize to calculate first? Pamela says that the order of the operation should be carried out in parentheses first, and then the exponents. And M stand for multiplication or division, and addition and subtraction. Here we have exponents, which is 3 squared, and then we have the multiplication, which is 4 times 3 squared. So we have the E and the M. E stands before M. We have to carry out the exponent first. 3 squared is going to be 9. So that would be 4 times 9. 4 times 9 is 36. Exponent evaluate first to 9, and then we write out the multiplication again. 4 times 9 is 36. Moving on to the second expression, which is the parentheses of 4 times 3 raised to the second power. In this case, we have the parentheses and the exponents. We have the P and we have the E. Which one goes first? That would be the parentheses group. P goes before E. Inside the parentheses, that would be 4 times 3. So we calculate parentheses first. So 12 raised to the second power, that would be 12 times 12. That would be 144. 36 is not the same as 144. So these two expressions are not the same. On the next example, we have negative 4 in the parentheses to the second and negative 4 to the second, but in this case, there is no parentheses around negative 4. If we have negative 4 in the parentheses raised to the second, meaning we have to get negative 4 times negative 4 itself, right? This exponent 2 applies to the entire parentheses, and in the parentheses we have negative 4. So negative 4 parentheses raised to the second power, meaning negative 4 multiplied with itself, negative 4. Carry out the operation, we have negative times negative is going to be positive. And 4 times 4 is 16. The answer is 16. In the second case, where there is no parentheses, we have negative 4 raised to the 2, right? This negative is actually a negative 1 times 4 to the second. Negative 4 is negative 1 times positive 4 is equal to negative 4. So in this case, we write out negative 1 times 4 raised to the second power. So here we have a multiplication and then an exponent. Looking at the PEMDAS, M multiplication goes after E exponents. So we have to prioritize exponents, right? So 4 square, meaning 4 times 4 itself, and then we write out -1. We are not touching -1, just solving the exponent, right? In this case, multiplication, there is no other operation, so we can carry out the calculation from left to right. -1 times 4 is -4 times 4 is -16. In the first case, if we have the parentheses, the answer is 16. And in the second case, where we do not have the parentheses, the answer is different. That will be -16. If we are given an even exponent, we will always yield a positive result. If we have like -3 raised to the second power, again, that will be -3 times -3. That will be a positive 9, right? Because this exponent applies to the entire -3. So if we have -1 to the 6, right? 6 is an even number, so that will be -1 times -1 times -1 6 times. So these two are going to be positive because negative times negative is positive, and this is negative negative is positive, this is negative negative is positive, so all of them is just a positive, and then 1 times just times 1 by itself is going to be positive in the end, so that would be 1. And even exponents always yield a positive result. Meanwhile, an odd exponent would not affect the sign. If you have a -2 raised to a -3, we will treat this number as a positive exponent first. So that would be -2 raised to the third. So that would be -2 times -2 times -2 by itself. So a negative times a negative is going to be a positive. But then a positive times a negative again is going to be a negative. And then 2 times 2 times 2 is going to be 8. So that would be -8. We have a negative exponent, right? So now we have to flip the number -8. So -a is -a over 1. So now we flip it. That would be 1 over -8. So the answer, -3, is going to be -1 over 8. Notice the sign negative still stay the same. So again, to reiterate, an even exponent, an even power, always give you a positive result, and the odd exponents do not affect the sign. Some more examples. -5 to the third, -5 to the third, that will be a -1 times 5 to the third, right? This negative can be treated as a -1. So here we have a multiplication and an exponent. And according to PEMDAS, we have multiplication comes after exponents. So we have to calculate the exponent first. So that would be 5 to the cube is 5 times 5 times 5 times 5 itself 3 times, and that is 125 multiplied by -1, so that would be -125. -4 to the -2, so -4 to the -2. Again, there is no parentheses around -4. We should separate it into -1 times 4 to the -2. This is multiplication, and this is exponents. We should prioritize exponents again first. 4 to the negative 2 is going to be, this is a negative exponent, so we should treat it as a positive exponent. So 4 to the second power, that would be 16, right? And now we have to flip 16, so to 16 over 1. The reciprocal of 16 over 1 is 1 over 16. This 4 to the negative 2 is going to be 1 over 16. This part is going to be 1 over 16. So then we multiply it with negative 1. So 16 times negative 1 is negative 1 over 16. We have negative 3 in the parentheses raised to the negative 3 power. So we have a parentheses surrounding the negative 3, meaning this entire exponent is applying to the parentheses. So we do not want to separate negative 1 and 3 like the previous example. This is a negative exponent, so we want to convert into a positive exponent, right? So that would be negative 3 in a parentheses to the third power. That would be negative 3 multiplied by itself 3 times. Negative times negative is going to be positive, and then multiplied by a negative again is going to be a negative in the end. And 3 times 3 is 9, and then times 3 is 27. So now we want to flip negative 127. This is equal to negative 27 over 1. And then we take the reciprocal of negative 27 over 1. That would be negative 1 over 27. Negative 3 parentheses. Negative 3 is going to be negative 1 over 27. So that is how you do exponents.